Hello. Okay, I'm back with another stream. Haven't streamed in quite a while now. Uh, Mostly been busy with other things happening in life. I'm back, and today I'm planning to explore the QMK firmware. Uh, as I said earlier, I'm in the process of making an Ergodox keyboard, and QMK is the firmware commonly used with that. So I am trying to figure out how to take the customizations that I have done on the microcontroller end and bake them into the firmware so that the keyboard will actually work. Now, I haven't explored QMK before. In fact, I haven't done any C programming in maybe a decade now. So it should be interesting. Plan is to start with just reading the docs a little bit for QMK. Uh, Build it locally, try to flash it on the microcontroller, see if it boots up and shows up as a keyboard, and start from there and try to put my customizations into the board itself. Okay, so that's the plan. This might be a shorter stream. Let's see where it goes. Okay. So I have the QMK docs website here. Quantum mechanical keyboard firmware. Interesting name. So this is a fairly active project. A lot of people contribute to it. A lot of keyboards and custom firmware versions in there. What I need is I need to look for something that uses two Arduino Pro micros on two halves of the Ergodox split. So very quickly, here is the Ergodox board I'm using, and yeah, I have three of them, but I'll use two. Right, so the idea is that we will have an Arduino Pro micro on each of these sides, controlling one half of the keyboard and then communicating across. So with that, let's see where we go. Okay, I do have a Pro micro sitting here. Anyway, so what all have I done so far, right? What I did last time was, and this was some time ago. When was it? Yeah, September 6th was the last edit. So if I go back to the screen share here, I made this optimized mapping. What this is trying to do is the boards originally use a Teensy 2.0 microcontroller, and what I have is a Arduino Pro microcontroller. So they aren't compatible on the actual board pinout. So I have to do some mapping. And in previous streams, I have gone through some of the stages of figuring out what that mapping could be. And my idea was, if I can minimize the amount of hand wiring I have to do, that would be good. So here is where we ended up. A lot of the pins are hand wired. A lot of the pins are direct header pins, which means they can directly be soldered onto the board. But this requires some bit of changes on the firmware side, right? So I need to tell the firmware which row is connected to which port of the data lines of the Pro Micro. And the other complication is that this Pro Micro will be a split setup. In the original board, it contains a Teensy on the right hand side and a IO expander on the left hand side. So let me show that to you. So this is the layout, right? And what the actual board looks like is once you have them attached, the Teensy microcontroller sits here, communicates with the other half via a cable connecting the two halves, and then there is this IO expander here. The IO expander actually extends the matrix scanning range of the Teensy onto the other side. Now I don't have this expander, so I am instead using another Pro Micro on this side, and this setup is supported in many boards. Today what I'll try to do is try to find a board which is closest to this setup. So an ergodox like board, preferably with similar number of keys, so the actual keyboard matrix is similar, and then something that can be customized with my pin to row, pin to column mappings. Okay, so that's the idea. Let's see. So two parts here, right? With this mapping, what I figured out was, let's say, how many? 9 and 9, 7, 17. So 9 and 18. 18 out of the 24 pins can be direct pass-throughs. So I don't have to do anything there. Just do some software adjustments so that I can actually use that in the firmware. So the software part of this setup is what I'll try to read up on today. As I said, I have not done much of C programming in almost a decade, but I did a lot of it before. So it should be fun coming back to C after a long time. And I certainly don't have any experience with QMK, but let's see how difficult or easy it is to figure out. Cool. So I was off stream looking at a few boards. I found one last stream, which is called Ergo Dash. And the good thing about this one is that it has, let me see if I can find the actual board's description. Good, there's a picture here. So the layout is different than what I am making, but apart from the layout, the board uses a 2 Arduino Pro Micro setup and is similar enough that this is derived from the original ergodox design, hence the name Ergo Dash, I guess. So that's what I was trying to do. As this says, it uses the Pro Micro, right? And this is what the layout looks like. It seems to have support for all the pins or all the switches that are on the ergodox. So here are a few options, right? So they have, apart from the switch position changes, the number of switches seem the same. So this thumb cluster on the ergodox, as I'll show you in a minute, the thumb cluster on the ergodox supports various layouts, right? So it will allow us to, come on, focus. I guess there's not a good focus day, but essentially it has 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7 switches can be supported. So 2 large switches and up to 1, 2, 3, 4 small switches. And I guess there is some flexibility on the board itself in where these can be placed. As you can see, there are the larger holes tell you where all switches can go, right? So I can have either two U keys, or I can have 1, 2, 3, 4 1U keys on this side, and these two are 1, 2, 3, 4. So this corresponds to the options you see here on the Ergo Dash keyboard, which is encouraging because this allows me to pick a little bit of pick from a few options, right? And the cluster isn't identical, but it is similar enough. Ultimately, in the firmware, there'll just be scan lines for the rows and columns of the keyboard. So that's where I'm going. Let's see. So I'll pick which cluster I want to actually use in the setup later, but might go with something like this. The first one. but the main idea is, will this firmware work for my PCB, which is an ErgoDocs PCB, not a Ergo Dash PCB? It should basically work. And since I'm going to customize the firmware a little bit anyway, I have the flexibility of bringing in some remapping of keys and so on at that point. Okay, let's dive in. Layout notes in thumb cluster. It's not possible to use all 5 positions as small keys. Okay. So the thumb cluster here is a little different. Let me just look up the ErgoDocs itself. Right. So as you can see, the thumb cluster of the ErgoDocs is much bigger, and hence it might have a few extra keys to scan here. So what we'll try to do is, the firmware is written for a specific board layout, and by attempting to use the firmware of a different keyboard on my boards, which are essentially for this keyboard, I'll not be able to use it as is. So that's where the customization of the QMK side on software, on the C coding side comes in. So now let's look at what QMK is and how it is built. Again, this is new to me on the QMK side, but let's see. Right. So there are a few revisions of this board. Let me pick out one file here. So there's a config.h file, which essentially has these matrix row pins and matrix column pins. Okay. So this is where I think the split part should be making some sense. So where's the split? This is for RGB. So wiring of each half. Okay, so this is half the keyboard. So 1, 2, 3, 4, 5 rows. Okay, and 1, 2, 3, 4, 5, 6, 7 columns. Nice. So okay, now I understand. So what this is set up as is, you have to build the firmware in 2 steps, one for the left half and one for the right half, flash each controller, and then they would, I think you'll have to choose what type of bus to coordinate over. It'll either be serial or I2C. Did I see that somewhere here? Okay, maybe they make a choice on their own. Okay, let's see. Good thing is it also supports alright, there are some settings here for serial, so maybe they use a serial connect between the 2 halves. Fine. I think we have some flexibility here. Mostly we want to get these 2 lines right on the Ergo Dash firmware. This is Rev 1, but that's fine. Good. So let me check. These are the pin numbers, as you can see on the spreadsheet. What I have here is, here are the pins that I'll be using. Right. So column E and column M are the pins I need to use. So the main point is, I'll have to figure out where each of the row numbers are mapped on the TNZ, and correspondingly where will they sit on the Pro Micro. That's what I've done here. So if you can see, these are port to port mapping. So instead of so whatever TNZ was accessing, let's say it was accessing for an example, I don't know the actual one offhand, we can look it up. Let's say it was accessing row 1 on pin B3. So row 1 in the hardware is mapped to B3, and it will appear on D1 in my design, in my microcontroller. So wherever B3 occurs in the file, I'll have to change it to D1, so that row 1 is recognized on AVR pin D1. Okay, and these are defined here. For instance, D4 is first row, second row, third row, fourth row, fifth row, 5 rows. And these rows are seen written down here. So one let me check the website again. How many rows does this have? 1, 2, 3, 4, 5. Okay, I think that's one difference. Okay, 5. Okay, no problem. I was just cross-checking whether I have the same number of rows or not. So 1, 2, 3, 4, 5. Yeah. So the firmware is compatible in the sense both have 5 rows. So we should be able to just pick the row assignments from this firmware mapping and update them with ours. Okay. So the reason I'm doing this on stream is it helps me to dedicate some time to doing this, and this is a late night stream for me. It's almost midnight here. So we'll see how long I can keep going. If anybody's around in chat and have any questions, please feel free to say hi. All right. Cool. So let me just check the board again. So here is row number 1, 2, 3, 4, 5. Sorry. Row number 1, 2, 3, 4, 5, as it says in the label here as well. And on the other side, similarly, row numbers 1, 2, 3, 4, 5. Okay, and this says it has 13 columns, but let me see if they're numbered from, yeah, so they're numbered from 0, so which means 14 total columns, 7 on each side. So 5 rows and 7 columns on one PCB. And looks like that's exactly what is set up here in, just make that font size a little larger. Looks like that's what is that's exactly what is set up here. So 1, 2, 3, 4, 5 rows and 1, 2, 3, 4, 5, 6, 7 columns. Okay, and fine. So as you can see, just mentioning the pins by name is enough here, and the diode direction is column to row. That I'll just cross check in my PCB what it is. I do not have a backlight setup supported on the PCB itself, but I am hoping that if I can get this extra pin, RGB diode pin, then I probably can try to set up RGB kind of layout. But I'm not a big fan of RGB lighting. I personally prefer just a simple backlight. So maybe I will just look at a single pin backlight level setup so that I can have an array of LEDs mounted under the PCB, which will give a nice underglow for the keyboard. So that's the idea. Right, so looks like this choice will work. And let me just see if there have been any updates to this recently. It's refreshing. Yeah, okay. So got it here. Now what I want to do is look a bit at the getting started guide, and I'm doing this on Linux, so I will need to look up how to build QMK on Linux and how to flash the firmware. So if I go to flashing, right, so this usually comes after the build step, but I just wanted to check what the, it should be just as simple as QMK flash, right? But we will see how well that works. If you're using Linux, I just switch flash the firmware from the CLI skip to the flash it. Okay, yeah, great. So QMK flash is the command once the build and setup is done. So let's start from the tutorial at the top. Open source community centered. Keyboards, mice, and MIDI devices. Hey, nice. That's new. I did not know this firmware works with mice also. Interesting. QMK configurator is the web-based, right? So this is the place where you can actually use choose the keyboard. Let's see if they have the standard QMK ones. Right, so you can see there's a Ergo Mini and an Ergo Rev 1. So I would probably be using something like the Rev 1 here, and then one can go and create mappings, finally get a firmware file so get the keymap JSON. So this is like a web-based utility to configure QMK as far as I can see it. Give it a name and so on. What's that? Cool. So this looks reasonable. What is QMK toolbox? Collection of flashing tools. Hoping this is not needed. If it supports these bootloaders, that's good to know. Windows and Mac OS versions are available. Okay, so not for me. I need a Linux version. So QMK toolbox probably won't work for me. That's fine. What is QMK.fm? That's the main homepage. Cool. Select your keyboard and program your keyboard. We have an introductory video. Great. So this method would work if you are using one of the existing keyboards inside QMK. I think this will allow you to just download the actual hex file which needs to be flashed and make it yours, as it says. But flash it. But we want to customize the source a little bit, so that's where we are going. So we will follow up on the use the source option here. Great. So there are setting up, building the firmware, flashing the firmware, testing. Great. So this looks like the right setup to follow. Let me just check if there is anything else here. That's it for now, I think. All right, complete newbies guide to QMK. That's me. Complete newbie to QMK. This is computer keyboard as a processor. Thank you. Processor runs software that's responsible for detecting button presses. Firmware fills the role of that software, detecting button presses and translating that onto the key code, as far as I can remember. Okay. The guide is suitable for anyone who wants to build a keyboard firmware using the source code. If you're already a programmer, you'll find the process very familiar and easy to follow. Good. If the thought of programming intimidates you, please take a look at our online GUI instead. we'll skip that. We are comfortable with programming here, so it's okay. Setting up the environment, building the firmware, flashing the firmware. Okay, cool. Let's get started. So setup. If we build key maps, it only has to be done once. That's fine. Text editor, we already have. QMK toolbox. An optional graphical program for Windows and Mac OS again, so not exactly for me. I'm on Linux here. Shells are fine. Prepare your build environment. That's fine. We'll skip those. Windows, Mac OS, Linux. All right. So let's see. This needs git python 3 pip. I think we have all these installed, but let's just make sure anyway. Git python 3 pip. Just run this again. So what I had done in advance is clone the git repository of QMK firmware from github.com QMK firmware git. Right. So we have all of these, I'm pretty sure, but I will still okay. So as you can see, we have git python 3 pip. I think I have 3.8 is the default for Python 3. Fine. I also have 3.9 installed here, but that's a different story. Okay. Install the global CLI to bootstrap your system. Right. So this should add the QMK command for us. Python 3 pip install user QMK. Right. So this will install in my user directory. I don't want to do that. I want to make a separate virtual environment for this. So what I'll do is virtual env venv is the name of the directory, and let's try Python 3.8 explicitly. Right, so we have it. Let me activate that environment. Done. Right, so now back to QMK firmware. Which Python? There's nothing as so-called Python. So Python 3, right? Got it. So Python 3 385 looks good. So Python 3 pip install. Don't have to give user now because I'm actually going to install it at the inside the virtual environment. So let's see. Meanwhile, what happened to the music? There it is again. Fine, I think this thing worked. So I have QMK here. No worries. Okay, works well so far. Let's figure out what all QMK has to offer. We're done with this. Run QMK setup. After installing QMK, you can set it up with this command. In most situations, you will want to answer yes to all of the prompts. Okay. On Debian Ubuntu, it's possible, but you'll get an error saying something like QMK not found. Okay, great. That's fine. We are in a virtual environment. This should not happen to us, but good to know. Great. So they haven't described the questions we will be asked in this page, but that's fine. Let's figure it out. So QMK setup. Found QMK firmware at this place. Would you like to set as your QMK home. Yes. Wow. That is some horrible color choice there. Not sure if you can see, anybody can see this. I can't also see this. Yeah, this is better. Road configuration to home Droid config QMK ini, okay. But QMK doctor is checking your environment, okay. Detected Linux, missing rules for admin, DFU boards, STM32 boards, boot child boards. Right, so it's giving us a bunch of warnings for UDEV rules. Let's see if that comes out to be a problem. So it might need one of these utilities to actually flash the firmware. AVR dude is something that I've used before in a side project. Let's see where this goes. Would you like to install dependencies? Fine, go ahead. It's downloading those dependencies. Fine. DFU programmer, GCC AVR, yeah dude. As you can see, my CPU is running hot. 99 degrees Celsius. Wow. I'm curious what heats it up so much. So what is it? Mostly OBS. That figures. And in this case, DPKG installing all of the downloaded software. No worries, can let it be. Okay, that is something I did not expect. Cannot perform a user install. User side packages are not visible in this virtual environment. Yes. Now, is that going to be an issue? We'll see. It's something for me to remember. All right, it says all are installed because it's okay if it can't do a user install. It should see the correct packages in the virtual environment. Fine. Submodule has not been cloned. Right, these should all be cloned. So looks like QMK uses Git submodules, which means it is now going to clone each of these repositories in. Just waiting for it to go through. Meanwhile, test. So now that your QMK build environment is set up, you can build a firmware for your keyboard. Start by trying to build the keyboard's default key map. Make sense? You should be able to do that with a command like QMK compile KB name of the keyboard key map default. Okay. So the KB should point to the exact subdirectory and key map default. When it is done, you should have a lot of output that looks similar to this. Firmware is fine and it will tell you how many bytes are free compared to the board. Okay. Configure your build environment. You can configure a build environment to set the defaults and make working with QMK less tedious. QMK config. Alright, so this will allow us to choose a default keyboard and a default key map so that we can just do QMK compile. Fine. It's okay. Problems detected. Please fix these problems before proceeding. Right, what problems did it detect? Is it talking about this error, or is there anything else that I missed? Yeah, I didn't say anything else. Okay, maybe I will try running this one more time. So it should find the utilities. Okay, it is scribbling about the missing UDEV rules. It's pointing to the same page for everything. Detected modem manager without the necessary UDEV rules. Please either disable it or set the appropriate UDEV rules. If you're using a Pro Micro, we are using a Pro Micro. Right, so open the link. On Linux, you need proper privileges to communicate with the bootloader device. You can either use sudo when flashing firmware or place this file into etc udev rules d. What file? Okay, let's see. Once added, run the following udev admin control reload rules trigger. With older versions of modem manager, filtering only works when not in strict mode. The following commands can update that setting. We'll check if this affects us. Serial device not detected in bootloader mode on Linux. Make sure your kernel has the appropriate support for your device. If your device uses USB ACM such as Pro Micro, which we do use, make sure to include config USB ACM Y. Okay. Other devices may require USB serial and any of its sub options. Okay. Right, so I think we have a QMK udev rules file. Let me read through this. Subsystems USB, vendor, got it. So vendor product, and it would add access to U access. Tag and run, input plug. So 32U4, this is what we have. I should check for whether this has the product ID that I have for my Pro Micro. Good. So let's plug it in. I think it's time. So I am tailing a log here, and I'll do LSUSB again later. Okay. Time to check this. So I am going to plug in the Pro Micro and see how it goes, because I need to just confirm the product ID. Okay, good. LED blinking sounds reasonably good. Back to the screen share. What I have here is Arduino Leonardo. Where is the product ID? Yeah, 8036, but the vendor ID should be okay. I don't see this product ID, so maybe what that means is it doesn't need this. Yeah, so it says Leonardo here, 80360. Okay, so it's possible that this version of Leonardo that I have, 8036, is not listed here. So yeah, that's a bit strange, because if it needs any special handling, it should be listed here. So it's possible that I might have to add a rule for this, but let's see if that goes that direction. We'll know. Got it. So at least I can grab this file. All right, go back here. Mhm. Rules.t. What do we name this file? What? 50 QMK rules. Fine, this is done. Okay, so where were we? Right, so we're trying to run this and we had gotten an error talking about the Linux udev rules, and music has stopped again. Great. Okay, back to work. So we did this, we got here. etc udev rules D, and now it's asking us to reload the rules. Fair enough. So rules reloaded. No change here. Trigger. Okay, you would have Adam trigger. Anything changed? Nope. It didn't seem like it changed, so it didn't immediately trigger maybe, but let's try the setup again. Right, so missing udev some master boards, no problem. Detecting modern manager without necessary udev rules. I wonder why it's still saying this. Is it because of the modem manager version? Okay, it's in a package called modem manager apt show version 1.12.8, and there was a warning about 1.12, less than 1.12, so with older version. So we don't have an older version, this is fine. Okay, maybe I should. So why it's still cribbing about that? We added the UDEV rules and okay, mass drop. We don't have a mass drop board, so maybe I can skip that one. But detected Monday manager without the necessary UDEV rules. Okay, maybe it's because of the mass drop board trigger. Okay, I think there is a catch here. Somehow the so why is it that although there are mass drop boards, so at least one of them listed here, it is not detecting in QMK setup. Okay, at this point I think I am encouraged to just proceed because we don't have a mass drop board, and if this is just a check for this rule, then we might be okay because we are not going to use a mass drop board. So maybe we can proceed at this point, but might have to come back here. Okay, so this is fine. We are done with setup. So now we want to compile a keyboard. And which keyboard? So we had picked something here, right? That is the Ergo Dash Rev 1. So let's try that. So right. Okay, time to compile it. Let's see if this works. So QMK compile -kbe -km. There it goes. Compiling keymap. Okay. Looks good so far. What did it do? Nice. So firmware size is fine. So many bytes free, 62%. So ergo dash rev1 default.hex. Now I want to check what all key maps are available. Of course, a default one would presumably be available, but what else? Yeah, I'm skipping the configuration. Create a key map. Right, so create a new key map. It will create a copy of the default key map. Fine, but what I'm confused about is how do I check which how do I produce two two key maps to flash? So let's say we have built this thing and we want to flash it, customize it to your liking, basic keywords, right? So we will have to come back here because every time we make a change in the key map, we will have to rebuild the firmware, and now we have to flash it, right? So now that you have a custom firmware file, you will want to flash your keyboard, put your keyboard into DFU bootloader mode. In order to flash your custom firmware, you must first put your keyboard into special flashing mode. While it is in this mode, you will not be able to type or otherwise use your keyboard. We don't have a keyboard, so it's fine. It's very important that you do not unplug the keyboard or otherwise interrupt the flashing. Basic hardware hygiene. Different keyboards have different ways to enter this mode. If your PCB currently runs QMK, bootmap a client, you have to hold down both shift keys. Nope. Press the physical reset button. Now I do not have a physical reset button here, so I'll have to go and look for how to put the Pro Micro into DFU mode. Okay, QMK flash KB keyboard key map. This will check the keyboard's configuration and then attempt to flash it. This means that you don't need to know which bootloader the keyboard uses. Just run the command, let the command do the heavy lifting. Great. Does rely on the bootloader being set by the keyboard. If this information is not configured or you are using a board that doesn't have a supported target to flash it, you will see this error. Right. In this case, you'll have to check back and define the bootloader, test it out. Should I just go ahead and flash this? Locate the header pins on the PCB labeled reset and ground and short them together while plugging your PCB in. Right, so I think we need to go back to the pinout here. So where is the reset pin? Pin 1 is ground on the Pro Micro as well. Where is the reset pin? So I will look up the Pro Micro pinout. Ground and reset. So it's the last two pins. No, not the last two. Actually, it says it has a silk screen label, RST and GND. Those are the two I need to short, while being careful not to short anything else. Okay. Right, so one thing I will do here is try and use a breadboard cable just to be sure. Right, so we're targeting the second last and the one beside that to be shorted while the keyboard is unplugged. So, okay, first things first, unplug the keyboard. Right here, it should say being unplugged. Great. Now, moment of truth. Right, so what I'm going to do is I'm going to try and use this board. Oh, come on, focus. These are the last two pins. I'll have to fix the focusing on this camera somehow for the next stream, but I guess for today we'll just have to continue. These don't fit really well, do they? Because they're meant to go on breadboards, not on. Now, the issue is that I haven't yet soldered the headers in here because I did not know which all headers I will need to solder. Okay, so I will try to do something here. Okay, maybe what I need to do here is just see if these go in like this. And I'll have to plug it in as well at the same time. Got it. So if I manage to burn this one out, I will have to dig into my spare, but let's see if this goes into bootloader mode. And I do believe you should get a visual indication of that as well. Why did it go out of bootloader mode? Did it? Yeah. So what happened here? Let's go back here. So it got connected. See, earlier it had just said new device found 8036, and here it says 0036. Okay, I think that's the best part. So whatever it is loading with is some sort of a default product ID called 8036, but this time what I got was a 0036, product 1, serial number 0, manufacturer 1, product 2, serial number 0. All right, got it. So this seems to have gone back into its default operating mode, where it appears as a mouse and a keyboard, which is fine. So the point being that there is a bootloader product ID, it seems, which is the 0036, and this is the one which we saw in the QMK file as well, in the udev rules file. Got it. So I think we are on the right track here, just that for some reason this has gone back into okay, so disconnected, going back to side view. Ah, okay. So there is this 8-second timer there, I think. Got it. I remember reading somewhere that you have to be a little quick with this, isn't it? So I'm assuming this is already done. Let me just make sure. It isn't here. This is just a layout, which we will be coming to later. Rev1 rules MK. Okay. Backlight enable no, RGB light enable no, audio enable no. Fine. Audio. What does audio have to do with a keyboard? Interesting. Remove old Pro Micro boot roller, load the jump instructions. I'm wondering where. Sorry about that. So I'm wondering where this is skipping up. Got it. So this is just the layout, which is fine. Audio enable play song on init. Interesting. Yeah, got it. So config H is where we were looking for. So if this works well, then it will come back to 6060 FEED after rebooting, and 10 rows 7 columns is the matrix size. Got to go tracking term C6 audio. Yeah, all this looks good. So in key maps, right, so there are a lot of key maps in here, and we can create another one for ourselves as well. This is the key map C. It should just contain, yeah, so as you can see, this is how the keyboard will finally look like. We don't have to go there yet. We are in Rev1 still. So checking where we have we, okay, so let me just go into the Ergo Dash directory. Then do git grep acm. It's not there anywhere. Wondering what's happening here. So what does the bootloader say? Make sure your kernel has appropriate support for your device. If your device uses USB ACM such as Pro Micro, make sure to include config USB ACM equals Y in the kernel. Yeah, I think this is configured because we were getting USB ACM messages from the kernel, so we should be good here. Here you go. It says TTY ACM0 USB ACM device, and as you can see, after a few seconds, how many seconds? Exactly 8 seconds, it disconnects. So what I had read somewhere was that when you're going to reset mode, you have to be a little quick, and it should be picked up by the program which needs to flash it, or something to that effect. Let me read through. Right, so flashing firmware. Put your keyboard into DFU mode. In order to flash firmware, it's important that you not unplug the keyboard, otherwise it'll take fine. Once we get the physical reset button, this should just be good, but we might have reset and ground, and we did them. We did short them. It did go into that mode, but 8 seconds back, 8 seconds later, it should come out. So did we get? Okay, if you have attended log to no avail and the main chip on the board says STM32, it may be a bit more complicated. Generally, your best bet is to ask on Discord. No, it's not an STM32. It's likely some photo of the board will be asked for. Okay, otherwise you should see a message below similar to this in the QMK toolbox. No, I don't have QMK toolbox. Right, so if you go here, when you are ready to compile and flash your firmware, open up your terminal window and run the flash command. Okay, so I think what we should do is run the flash command and try it out. Okay, so I have just unplugged the board. Let me go back here. It's disconnected. So what I'm trying to do here is this stuff, the highlighted items on second 13 onwards is the firmware, the actual programmed firmware booting up. Till here it was just the bootloader. So you can see that at 05 it booted up into the bootloader mode, I think, and after that exactly 8 seconds later it boots up into this thing. So let me just search once for Arduino Leonardo 8 seconds boot. Pro Micro 8 seconds. Anyone with an Arduino Leonardo or Micro or Explorer knows that after a reset, the board will wait for about 8 seconds before running the sketch stored in the flash memory, right? This waiting is marked by the flashing of the integrated LED. This delay has been inserted to let the user to flash a new sketch. However, this time is objectively too long. Okay, so it's essentially saying that it's too long. Thanks to the presence of the sources or open source, we can modify the bootloader to adapt. Here's the directions, change the delay to only 3 seconds. Yeah, we don't need all of this. Okay, so somebody here is connecting access the power reset button. When a power device, it takes about 8 seconds before my sketch begins to run. If I run a sketch from the ID, it runs immediately. Okay, I think this might be a little complicated to do without having pins soldered onto those pads, because if you have to do rapid removal attaching off the board, that'll be tricky. Okay, one thing I can try right now, and correct me if anybody has experience with this. I want to try out QMK flash without doing any of this and see what happens. Oops. Detecting you reset your controller now. Okay, great. So this thing says it's waiting for the controller to be reset. So if while it's waiting I reset it, it should pick it up. This is what I was trying to hope for, right? And let's put these side by side. Right now there's nothing here. It says resetting your controller now. Here it goes. So this time I'll just attach it while in this mode. Let's see. Pick it up, please. What? It didn't do anything. Device TTY SM0 has appeared, assuming it's the controller waiting this to be writable. It's not writable yet, but it has already booted back into 8036 now. Yep, that didn't work. And I think we have to start this again as well. Okay, let's try that one more time. Go to flash mode. Reset your controller. Now it says. And I think the next thing I will try is, because QMK seems to be progressing nicely, so the next logical thing for me to try is actually soldering the headers onto the microcontroller so that I can there you go. Oof. Good. This looks good. Awesome. Nice. Let's read through. So I think what I had to do was leave the reset pin up, and as soon as I did that, it recognized it as ACM device. 32 USB disconnect, new post speed device. Oh wow, it took just those few seconds to flash it. Wonderful. Um, Waiting for it to become writable. It did become writable at some point. Then it connected to the programmer. Interesting. Uh, Found programmer ID getter in. Software version 1, no hardware version given. Programmer supports auto address increment for the following devices. AVR device initialized to ready to accept instructions. Reading device signature. Probably M324U. Yep. Note flash memory has been specified and erase cycle will be performed to disable this feature. D, no. Erasing the chip. Reading file or crash F1 default. But file is fine. 1.35 seconds. Great. So many bytes written. Verifying. Load data flash data from this. AVR to input file. Auto detected as Intel hex. Verified. Safe most uses okay. Thank you. Wonderful. All right, so this looked good. Now, I think the best part is even this looks nice, right? So it says here OMKBD Ergo Dash is what has been recognized now. And earlier we were seeing the vendor ID as 2341 and product ID as 8036, but now we see vendor ID as feed and product ID as 6060. Which is exactly what is specified in the firmware file for the Ergo Dash. Okay, system control, consumer control. Nice. This looks good. So I think this flashing of the firmware which we just built has been a success. Next steps for me are to go back to the firmware and try to mod it as per the key map that not the key map, the pins that I need to use, and in particular modify these files, the rev1 config, yeah, these two lines. So if I am able to modify these two lines, it would allow me to like here is where we would go, right? We would say where does so what I need to see is what was so it's a little bit tricky here. I need to check which pins each row of the PCB appears in. So where is row 1 to row 5 or as per the TNZ, which port, and then take the mapped port and put it here. Got it. So I already have the mapping between the TNZ ports and the ProMicro ports in the spreadsheet. So for instance, if row 1 goes to B3, I'll be able to send it to D1 or use D1 in the firmware. But what I do not have is where does the row 1 of the PCB end up on the TNZ. So I have to go back and study the circuit diagram of the Ergodox PCB and check and note down all of the pins on which the rows and columns of the keyboard appear. All right, I think I'll do that next stream. It's 1 a.m. here, and I guess I need to get to sleep. So again, it's the main reason I'm doing this on a stream is so that I can just concentrate, take some time, and go through these steps that I need to do to build this custom mapping. I wish it was easier that for me to just use it. So if I could procure a TNZ 2.0, I would just use it in the PCB and be done with the build. But I guess it would also be less fun that way. Here I've been able to take some time to figure out this hack of using a ProMicro on a PCB that was designed for a TNZ. And my intention is this. I'm not sure if anybody else will be interested in doing something like this, but I will put this all up on a GitHub repository and share it towards the end of this series. But the next order of events for me is to take the pins from the PCB, row and column pins, and you do the correct selection as per the mapping I have done here. Once that is done, I should be able to just build the firmware like I did for the stock firmware of the ErgoDash, flash it. Now one thing I need to figure out though is, how do I build the two separate sides of the PCB? How do I get a hex file for the left and the right? Because I'll have to flash the ProMicro twice, right? It's an interesting one, right? It should have some instructions in here because the ErgoDash works that way. So let's look at the ErgoDash documentation. So there is a make ErgoDash drive one default, make instructions in the doc. This is fine. Now one big assumption I have here is that the matrix row and column mappings are the only difference between this PCB and the ErgoDocs PCB. That's not entirely true, because I should just check that from the actual circuit diagram. What could be different is, for instance, the diode direction could be different between the PCB of the ErgoDone and the ErgoDocs. The number of rows and columns are different, so that's another variation. But as long as the differences are limited to software, I think we have the opportunity to figure it out and not be overwhelmed by just going after getting the right hardware, right? Cool. So that's where I will probably end the stream today. Been streaming for about an hour and a half, which is good. I have not been very regular with the streams, but it's for good reasons, so that's fine. And I hope to be back next weekend with the next part of this firmware mapping. Till then, a few things I will do offline are, I will pick out the places, get the circuit diagrams extracted. It's a little hard to figure this thing out on the PCB itself, but unless there are silk screens, which there aren't here. So I will look into the circuit diagram of the ErgoDocs and the ErgoDone, check which pins I need to remap, and I think that's a good place to start. Nice. And what else? So I'm surprised that they don't have like visible instructions on how does one do pro micros for each side. Should be some instructions, right? Okay, let's look at their own repository. Right, so this guide is something that we should look at more seriously. Let us look through the, I want to look through the build guide here, because wow, beautiful diagram. I wish people would put so much effort into their build documentation in software right now. Yeah, okay, installing diodes is fine. Pro Micros. Ah, interesting. Why are there two positions? Okay, one for each side maybe. What I want to find out is, do they somehow use the same exact firmware for both sides? Other side of the board, there are two locations for the Pro Micro. Pro Micro will be installed where the rectangle outline is printed. Yeah, this is specific to the board, but still, let's keep going. Looks like nobody turned up in chat today. It's pretty late for local people here, so I was not expecting anybody. Install stabilizer. This is fine. Yeah, this is the hardware build. Case assembly. Right. Is the QMK build guide. Dash firmware. If the right hand side is the master. Now, yeah, I was missing this part, so let me bookmark this. So if the right hand side is the master, you need to build the firmware by specifying master right in the config edge. All right. In the key map of QMK, to turn backlight and underglow, add the following rules to rules MK. As the default setting, underglow LEDs are on. Let me go back to the screen share for a minute. Yeah, so what I found on this guide was, apart from the hardware instructions, they have these really helpful firmware instructions, which is what I was looking for in the first place. As the default setting, underglow LEDs turn on, but backlight LEDs don't turn on. If you want to confirm whether LEDs work or not, press the toggle key. If you use firmware this or earlier, comment out the following in relevant config. Okay. Got it. So there is a switch on the config H file, which decides which side is the master, and I guess you have to switch the or plug in the USB cable into the master. Let's go there and check what's happening. Strange. Config file in the key map of QMK. Okay, I was looking in the wrong place. This is the division itself. Go into the key map, default, config H. This one. Yes, so use serial or use I2C. This is the part I was missing in the main setup. Got it. So select hand configuration, master left, master right, EE hands. EE hands is, I'm not sure what that means, but fine. Default, let's read the rest of the key map file. This is the layer names. Fine. This is just defining the layers, so this is good. Anything else in here? Audio enable, process default layer, process record user, layer on, layer off. Good. So this is just the code which works on the key map side. This is fine. And anything in the rules MK, backlight enable, audio enable, nice. Good. So what they're saying is define master left or master right based on which side has to be the master, and then rest of it seems to be the same. And we can choose what to use, I2C or serial as a way to connect, but not both. This is fine. All right, so I think we went through the main part of the build, or the customization preparation. Next step would be to actually make the changes, but for that I need to bring out the PCB or the circuit diagrams of both the ergo docs and the ergo done. Either one might help me out here, but one of them will be needed. Mostly I will look for the circuit diagram of the ergo docs, which I can redo now. Yep. This is the one I'm looking for, but maybe a better rendering of it or a PNG. No. Search the keyboard artworks. Let's look at what is inside QMK. They probably don't have one in there. Nope. Yeah, it's fine. I think I will look for, so this diagram looks familiar, but it's not really the one I'm looking for. Nope. I did find a very reliable circuit diagram which I was trying to verify, but maybe I should just forget about all that, bring out my multimeter, actually test it out, and that might be an easier approach. So maybe I'll do that. It also helps because there are slightly different revisions of these boards available, and I have the one by Dominic Buchan, so maybe I can open that one. Nice. Right, so you can see that they have, why do they say 6 rows? I can only see 5 rows. Where is row 0? Ah, the thumb cluster is a separate row. Oops. So that is tricky. If the thumb cluster is a separate row, then there has to be slightly different, a slightly different setup. Maybe. Okay, I will have to check if the firmware supports 6 rows. There is a flag here which seemed to indicate it does support. Right. Five by 6 key map. So maybe with different key maps I can choose different yeah, so 10 rows and 7 columns, right? Weird. Why are rows doubled up? Interesting. This one seems to connect row to row. All right. I think there is some extra compatibility issues that might come up because the way the Ergodox PCB seems to be built is 6 rows and 14 columns, whereas this setup is different between the two sides. So will just changing this here work, or I guess there is some experimentation needed, but I think it's possible because I'll have to look into the code as to how the matrix rows and the matrix columns these definitions are used. So if they are just scanning these in a loop as they should be, then just setting these to the right number as per my PCB and putting the right pins here should just work. But again, that's a thing to be verified. So there is some interesting stuff to be done in the next stream. All right, I think I will stop at this point. Thank you if anybody was here for dropping by. I think a few people were in the users in chat list, but nobody spoke up, which is fine. Next time I will announce the stream in a little bit advance so that people who are interested can make it to the stream. But for now, we will just call it a night for me and have a good week.